project was to take a look at aerosol emissions from fires and look at the transportation of these aerosols near the actual plumes of smoke near the fires. So the big thing here was taking a model that simulates aerosol transport and trying to evaluate the accuracy, the biases of this model. So I used a NASA model in-house called GOCART to simulate the transport of these aerosols and compare it to satellite observations. This has been done in the past a few years ago with some fire cases from 2006 to 2007, but due to the limited amount of cases and the undecided results, we continued the research into different years. So I took a look at 2008 cases. I used two different satellites. I used a satellite called MODIS and a satellite called MISR, which had not been done in the past. The reason being that the MODIS satellite has very large scan width and a very high resolution. MISR has a smaller scan width and lower resolution. You can look at the aerosols through the atmosphere at a bunch of different angles. It has 9 cameras, whereas MODIS has 1 camera. So MODIS tends to have issues with the retrieval of the aerosols itself. So in the previous research, it was found that across Northern America, in these blues and these darker colors, we can see that GOCART aerosol optical depth values, aerosol optical depth being the concentration of aerosols in the atmosphere. The model tended to underestimate significantly the aerosol optical depth across North America when compared to the satellite observations. So I used 2008 cases to see if my results would end up being the same for a different year of fires, because fires vary by year, so we wanted to see if using a different year might improve the model. So I used North America again and looked between California and Canada, because that's where the largest fires are. And I found when comparing the models, which the models are on the right here, the reds are higher optical depths or higher concentrations of aerosols. And comparing the satellites here to the model on the left, the satellite had much higher aerosol optical depth values than did the model when it came to Western California, whereas in Canada, the satellites actually at times would underestimate or were fairly close to the model output aerosol optical depth values. So there were quite some discrepancies, and you can see from the results here, these are the old results and these are the new results. You can see that again across Western North America, the model tended to underestimate the aerosol optical depth, but I found that across Canada, the model was doing a fairly good job, and at times it actually overestimated. And there's a lot of different theories as to why this happens. One theory is the model runs off a spatial grid of 1 degree by 1.5 degrees. So the further north you go, degrees of longitude become closer together, and so it's a higher resolution. Another possible reason is that the satellites, there has been research done showing that the satellites have biases of retrieval themselves, so it could be possible that the retrieval from the satellites had some biases. It could also be possible this model needs fire aerosol emissions inputted into it, and these emissions are retrieved from other satellites, so it could be an issue with those retrievals. So there's a lot of further research that needs to be done to see whether it's the model that's creating these biases or the satellites or what is causing these biases, so that we can work on this model and make it a more accurate model, and ultimately be able to predict out the transport of aerosols from fires, so we can have much better air quality forecasts in the future when it comes to wildfires.